Hello, my name is Vignesh, and this is the fifth lecture in the math lecture series. So today we're going to be going over expressions and specifically polynomials. So there's three different question types in this. So the first one would be combining like terms, and this is basically where they'll give you two expressions and they'll ask you to add or subtract the two expressions, and in that case you have to combine like terms. So if I give you an example, if it's 6x squared plus 6x, and that's one expression, you'd add that to another expression which is 5x squared plus 5x. You'd add the 5x squared and 6x squared, you'd combine them to get 11x squared, plus you'd add the other two like terms, 5x and 6x, to get 11x. So that's like a simplified version of that. So and remember, when you're doing that, make sure that the variables match completely, so that so like you couldn't do like 5x plus 5xy, because that would just equal 5x plus 5xy. You can't combine the two terms, and that the exponents like match. So for example, 3a squared plus 2a, that wouldn't work because the exponent's different. Like here it's 2, here it's implied 1. So in that case, if you were adding them, it would just be 3a squared plus 2a. You can't combine them. Next, we have expansion and factoring. That's the second question type. Here, it's basically they'll give you a factored equation and they'll ask you to expand it using FOIL, or they'll ask you to already take an existing expression and factor it. So an example using FOIL would be like, let's say you had x plus 3 times x plus 2. Here, I would using FOIL would be x times x, so that's equal to x squared. Then 2 times x, which is plus 2x, plus 3 times x, so that's plus 3x, plus 3 times 2, which is 6. So then if you simplify this, it would just be x squared plus 5x plus 6. So that's how you would expand an equation using FOIL. In another case, you would have to factor it. So for example, if you had x squared plus 4x plus 4, that would just be x plus 2 times x plus 2. And how I did that was, or it could be x plus 2 squared. And how I specifically did this is I know that the 4 here has to be the sum of the two numbers, and the 4 here has to be the product of the two numbers. So 2 plus 2 is 4, and 2 times 2 is 4 as well. And also some key like factoring tips, like equations here are listed below. So like I remember these notes and the practice problems at the end are going to be posted on Google Classroom. So I highly suggest you look over the notes if you need any further like help in written form, as well as if I would suggest you do all the practice problems and the answer at the very end. The final question type we're going over today is fractions. So this is basically where you get an expression in the form of a fraction. And like we all know, like do normal fractions. So like in this case, it'd be like in polynomial forms. Like one of either the numerator, denominator, or both numerator and denominator would be an expression. So when you're trying to add or subtract them, make sure that the denominator is the same. So like you can add x over x plus 3 plus x over x plus 2. You'd first have to make sure the denominator is the same. So how I would do that is I would just multiply x plus 2 to the top and bottom of this fraction. Sorry. So let me just write this in here. Sorry. So let's say I had x over x plus 3. I'm trying to add it to x over x plus 2. I can't do it now because the denominators are the same. So what I would personally do is I would multiply this times x plus 2 over x plus 2 and multiply this by x plus 3 over x plus 3. And that would give you a common denominator that you can then add and then simplify later on using the earlier ones. And when you're multiplying like fractions with polynomials, it's the same as if you're multiplying it with like normal fractions. So and then afterwards, if you needed to, you could use any of these two strategies, like the strategies in these two question types, to further simplify the equation. So now that I went over some of the tips and strategies, now let's do a couple practice problems on our own. So the first one I wanted to do was number 3. Like I said, all these practice problems and the answers are going to be attached on Google Classroom. So I highly suggest you go and do all these practice problems, as well as do some additional practice problems online on this question type, so you can further master it. Because the easiest way to study for the SAT is to keep doing practice problems so that you can you can see patterns and you can see all the way college will may ask you a question. So in this case, number 3, which of the following is equivalent to x squared plus y times times y plus z. This is just simple FOIL. So I first so I don't know how FOIL works. Is basically, let me write this out here so it's easier for me. So you basically multiply like something like this, where like you would have like 4 different terms, and you can like obviously I will do something real quick. So yeah, so here it'd be x squared times y, that's the first one, plus y times z, plus it'd be y squared plus x squared times z. I'm just following what I did there. And then obviously in this case you can order the addition any way you wanted to. And if you see for answer choice B, it's x squared times y. That's the first one. X squared times z. That's the last one. Y squared here and y times z. That's this one right here. So yes, that works right there. So yeah, so in this case, answer choice B is the answer if you did the FOIL properly. And then obviously, if you wanted to check your answer, like let's say you're doing this yourself, you can just look at the very end, and you see number 3 is B, and it gives you a quick explanation too if you need help on it. So, now why don't we do number 4, which the following is equivalent to 4 plus 8x over 12x. So here, if I wanted to simplify this, I recognize that all of these numbers are multiple of 4. So what I try to do is I try to factor out of 4 and both the top and the bottom. So if I do so, it would be 4 times 1 plus 2x, because 4 divided by 4 is 1, and 8 divided by 4 is 2. Ax divided by 4 is 2x, over 12x divided by 4, that's going to be 3x, so it's going to be 4 times 3x. And here, since the fraction, I can cross out the 4, and this simplifies to 1 plus 2x over 3x, and that's the same as answer choice C. Sorry, 1 second. Yeah, okay. Now we're going to be doing number 9. The expression above is equivalent to which of the following? So in this case, what I want to do here first is I want to take the numerator and the denominator, and I want to combine these two. So in order to do that, I would have to make the denominators the same. So I'd first do 2x over x plus 1 over x over 2x over x minus 1 over x. So I just multiplied the 2 by x over x, so I can like get a similar denominator, and that would become 2x plus 1 over x over 2x minus 1 over x. And then so that would just, and then if I would and if you're dividing two fractions, you multiply by reciprocal, so that'd be 2x plus 1 over x multiplies, I'm going to use a dot for multiply so I don't confuse myself, times x over 2x minus 1. Here the x's cancel out, so that leaves me with 2x plus 1 over 2x minus 1, and that's the same as answer choice B. And now for number 10, which of the following is the sum of the two polynomials above? Here, this is just combined like terms. This one, even though it says you can use a calculator, you really don't need one. So first you have 3x cubed. I would see is anything else have an x cubed? No. Again, you cannot combine these two terms because the exponent is different. So 3x cubed plus, now x squared is next. I see there is 2x squared, so I can add both of them because it is sum. So that equals 15x squared. Next, I see it's x, so I see negative 4x here and negative 11x. That added would be negative 15x. Finally, the constant negative 7. This one doesn't have a constant, so it's just negative 7. And if I see which one is this right answer there, that would be answer choice B. So yeah, so I hope this gives you a taste of like the polynomial expression questions on the SAT. And again, do the rest of these practice problems and check your answers at the end, as well as hopefully you'll do some more online. Like just search up online polynomial SAT practice questions, and you'll find a bunch of them. And if you need any help, you can email me or anyone else, any of the other instructors. So yeah, that's it for this video. Thank you so much, and wish you the best of luck.